Dragon 2. Dragon 2 is a class of partially reusable spacecraft developed, manufactured, and operated by the American space company SpaceX for flights to the International Space Station, ISS, and private spaceflight missions. The private spacecraft, which consists of a reusable space capsule and an expendable trunk module, has two variants, the 4-person Crew Dragon and Cargo Dragon, a replacement for the Dragon 1 cargo capsule. The spacecraft launches atop a Falcon 9 Block 5 rocket, and the capsule returns to Earth through splashdown. Crew Dragon's primary role is to transport crews to and from the ISS under the National Aeronautics and Space Administration's, NASA's, Commercial Crew Program, CCP, a task handled by the Space Shuttle until it was retired in 2011. It will be joined by Boeing Starliner, or CST-100, in this role when NASA certifies it. Crew Dragon is also used for commercial flights to ISS and other destinations and is expected to be used to transport people to and from Axiom Space's planned space station. Cargo Dragon brings cargo to the ISS under a Commercial Resupply Services 2, CRS-2, contract with NASA, a duty it shares with Northrop Grumman's Cygnus spacecraft. As of January 2025, it is the only reusable orbital cargo spacecraft in operation, though it may eventually be joined by the under-development Sierra Space Dream Chaser spaceplane. There are two variants of Dragon 2, Crew Dragon and Cargo Dragon. Crew Dragon was initially called Dragon Rider, and it was intended from the beginning to support a crew of 7 or a combination of crew and cargo. Earlier spacecraft had a berthing port and were berthed to ISS by ISS personnel. Dragon 2 instead has the International Docking System Standard, IDSS, compatible docking port to dock to the International Docking Adapter, IDA, ports on ISS. It is able to perform fully autonomous rendezvous and docking with manual override ability. For typical missions, Crew Dragon remains docked to the ISS for a nominal period of 180 days, but is designed to remain on the station for up to 210 days, matching the Russian Soyuz spacecraft. Crew Dragon is capable of autonomous operation. SpaceX and NASA state that it is capable of carrying 7 astronauts, but in normal operations, it carries 2 to 4 crew members, and as of January 2025, has never carried more than 4. Crew Dragon spacecraft includes an integrated pusher launch escape system, LES, whose 8 Super Draco hypergolic propellant rocket engines can separate the capsule away from the launch vehicle in an emergency. SpaceX company originally intended to use the Super Draco engines to land Crew Dragon on land. Parachutes and an ocean splashdown were envisioned for use only in the case of an aborted launch. Precision water landing under parachutes was proposed to NASA as the baseline return and recovery approach for the first few flights of SpaceX Crew Dragon. However, propulsive landing was later cancelled, leaving ocean splashdown under parachutes as the only option. In 2012, SpaceX was in talks with orbital outfitters about developing space suits to wear during launch and re-entry. Each crew member wears a custom-fitted space suit that provides cooling inside the Dragon, an intravehicular activity, IVA, type suit, but can also protect its wearer in a rapid cabin depressurization. For the Crew Dragon Demo 1 mission, officially Crew Demo 1, SpaceX Demo 1 or Demonstration Mission 1, a test dummy was fitted with the spacesuit and sensors. The spacesuit is made from Nomex, a fire-retardant fabric similar to Kevlar. The Dragon spacecraft's design was unveiled on May 29, 2014, during a press event at SpaceX headquarters in Hawthorne, California. In October 2014, NASA selected the Dragon spacecraft as one of the candidates to fly American astronauts to the International Space Station, under the Commercial Crew Program. In March 2022, SpaceX President Gwynne Shotwell told Reuters that, "We are finishing our final capsule, but we still are manufacturing components, because we'll be refurbishing." SpaceX later decided to build a 5th Crew Dragon capsule, to be available by 2024. SpaceX also manufactures a new expendable trunk for each flight. SpaceX's Commercial Crew Transportation Capabilities, CCT-CAP, contract values each seat on a Crew Dragon 2 flight to be around $88 million, while the face value of each seat has been estimated by NASA's Office of Inspector General, OIG, to be around $55 million. This contrasts with the 2014 Soyuz launch price of $76 million per seat for NASA astronauts. SpaceX Dragon 2 was intended from the earliest design concept to carry crew, or with fewer seats, both crew and cargo. The cargo version, dubbed Cargo Dragon, became a reality after 2014, when NASA sought bids on a second round of multi-year contracts to bring cargo to the ISS in 2020 through 2024. In January 2016, SpaceX won contracts for 6 of these flights, dubbed CRS-2. As of August 2025, Cargo Dragon had completed 10 missions to and from the ISS, with the 11th mission in progress and more missions planned. Cargo Dragons lack several features of the crewed variant, including seats, cockpit controls, astronaut life support systems, and Super Draco aboard engines. Cargo Dragon improves on many aspects of the original Dragon design, including the recovery and refurbishment process. Since 2021, Cargo Dragon has been able to provide power to some payloads, saving space in the ISS and eliminating the time needed to move the payloads and set them up inside. This feature, announced on August 29, 2021, during the CRS-23, also known as SPX-23, launch, is called Expendable. For CRS-23 there are 3 Expendable payloads launching with the mission, and once docked, a 4th, which is currently already on the space station, will be added to Dragon. For the first time, Cargo Dragon C-208 performed test reboost of the ISS via its aft-facing Draco thrusters on November 8, 2024, at 1750 Coordinated Universal Time. On SpaceX CRS-33, also known as SPX-33, Dragon included boost kit, propulsion module in Dragon's hollow unpressurized trunk, which is typically used to carry larger experiments that are robotically attached to the outside of the ISS. The kit comprises 6 dedicated propellant tanks containing hydrazine and nitrogen tetroxide, a helium pressure tank, and 2 Draco thrusters aligned with the station's velocity vector. The boost kit is based on, but operates independently from Dragon's primary propulsion system. When activated, the system can add about 9 meters per second, 20 miles per hour, to the ISS's orbital velocity, equivalent to the total reboost impulse of roughly 1.5 Russian Progress cargo vehicles, which are normally responsible for orbit maintenance. The kit carries enough propellant to provide about 1/3 to 1/4 of the ISS's annual reboost needs. The U.S. deorbit vehicle is a planned Cargo Dragon variant that will be used to deorbit the ISS and direct any remnants into the spacecraft cemetery, a remote area of the southern Pacific Ocean. The vehicle will attach to the ISS using one of the Cargo Dragon vehicles, which will be paired with a longer trunk module equipped with 30 additional Draco thrusters, in addition to the normal 16, and will carry 30,000 kilograms, 66,000 pounds, of propellant, nearly 6 times the normal load. NASA plans to launch the deorbit vehicle in 2030, where it will remain attached, dormant, for about a year as the station's orbit naturally decays to 220 kilometers, 140 miles. The spacecraft is to then conduct 1 or more orientation burns to lower the perigee to 150 kilometers, 93 miles, followed by a final deorbiting burn to push the station into the ocean. In June 2024, NASA awarded a contract worth up to $843 million to SpaceX to build the deorbit vehicle as it works to secure funding. SpaceX, which aims to dramatically lower space transportation costs, designed Dragon 2 to be reused, not discarded as is typical of spacecraft. It is composed of a reusable capsule and a disposable trunk. SpaceX and NASA initially certified the capsule to be used for 5 missions. As of March 2024, they are working to certify it for up to 15 missions. To maximize cost-effectiveness, SpaceX incorporated several innovative design choices. The Crew Dragon employs 8 side-mounted Super Draco engines for its emergency escape system, eliminating the need for a traditional, disposable escape tower. Furthermore, instead of housing the critical and expensive life support, thruster, and propellant storage systems in a disposable service module, Dragon 2 integrates them within the capsule for reuse. The trunk serves as an adapter between the capsule and the Falcon 9 rocket's second stage and also includes solar panels, a heat dissipation radiator, and fins to provide aerodynamic stability during emergency aborts. Dragon 2 integrates solar arrays directly into the trunk structure, replacing the deployable panels of its predecessor, Dragon 1. On cargo Dragon missions, the trunk can also be used to transport unpressurized payloads, such as the Rollout Solar Array, ROSA. Or it can be fitted with a boost kit to perform reboosts of the ISS. The trunk is connected to the capsule using a fitting known as the claw. The typical Crew Dragon mission includes 4 astronauts, a commander who leads the mission and has primary responsibility for operating the spacecraft, a pilot who serves as backup for both command and operations, and 2 mission specialists who may have specific duties assigned depending on the mission. However, the Crew Dragon can fly missions with just 2 astronauts as needed, and in an emergency, up to 7 astronauts could return to Earth from the ISS on Dragon. On the Crew Dragon, above the 2 center seats, occupied by the commander and pilot, there is a 3-screen control panel. Below the seats is the cargo pallet, where around 230 kilograms, 500 pounds, of items can be stowed. On the ground, crews enter the capsule through a side hatch. The capsule's ceiling includes a small space toilet, with privacy curtain, and an International Docking System Standard, IDSS, port. For private spaceflight missions not requiring ISS docking, the IDSS port can be replaced with a 1.2-meter, 3 feet 11 inches, domed plexiglass window offering panoramic views, similar to the ISS cupola. Additionally, SpaceX has developed a Skywalker hatch for missions involving extravehicular activities, EVA. The cargo Dragon is loaded from the side hatch as well as through the IDSS port on the ceiling. It lacks the control panels, life support, windows, and seats of the Crew Dragon. The spacecraft can be operated in full vacuum, and crew wears SpaceX-designed space suits to protect them from a rapid cabin depressurization emergency event. The spacecraft has also been designed to be able to land safely with a leak of up to an equivalent orifice of 6.35 mm, 0.25 inch, in diameter. The spacecraft's nose cone protects the docking port and 4 forward-facing thrusters during ascent and re-entry. This component pivots open for in-space operations. Dragon 2's propellant and helium pressurant for emergency abort and orbital maneuvers are stored in composite carbon overwrapped titanium spherical tanks at the capsule's base in an area known as the service section. For launch aborts, the capsule relies on 8 Super Draco engines arranged in 4 redundant pairs. Each engine generates 71 kilonewtons, 16,000 pounds force, of thrust. 16 smaller Draco thrusters placed around the spacecraft control its attitude and perform orbital maneuvers. When the capsule returns to Earth, a phenolic-impregnated carbon ablator 3, Pica 3, heat shield safeguards the capsule during re-entry. Dragon 2 uses a total of 6 parachutes, 2 drogues and 4 mains, to decelerate after atmospheric entry and before splashdown, compared to the 5 used by Dragon 1. The additional parachute was required by NASA as a safety measure after a Dragon 1 suffered a parachute malfunction. The company also went through 2 rounds of parachute development before being certified to fly with crew. In 2024, the use of the Super Draco thrusters for propulsive landing was enabled again, but only as a backup for parachute emergencies. Crew Dragon is used by both commercial and government customers. Axiom Space launches commercial astronauts to the ISS and intends to eventually launch to their own private space station. NASA flights to the ISS have 4 astronauts, with the added payload mass and volume used to carry pressurized cargo. On September 16, 2014, NASA announced that SpaceX and Boeing had been selected to provide crew transportation to the ISS. SpaceX was to receive up to $2.6 billion under this contract to provide development test flights and up to 6 operational flights. Dragon was the less expensive proposal, but NASA's William H. Gerstenmaier considered the Boeing Starliner proposal the stronger of the two. However, Crew Dragon's first operational flight, SpaceX Crew 1, was on November 16, 2020, after several test flights, while Starliner suffered multiple problems and delays, with its first operational flight slipping to no earlier than 2026. In a departure from the prior NASA practice, where construction contracts with commercial firms led to direct NASA operation of the spacecraft, NASA is purchasing space transport services from SpaceX, including construction, launch, and operation of the Dragon 2. NASA approved a new propellant loading procedure due to the Falcon 9 rocket's novel use of superchilled propellants. Unlike earlier NASA spacecraft, such as the Saturn V and Space Shuttle, where propellants were fully loaded hours before launch and before astronauts boarded, on the Falcon 9, propellants are loaded just before launch to keep the liquid oxygen near -340°F -206.7°C and the kerosene near 20°F -7°C. Propellant loading begins approximately 40 minutes before liftoff, with the launch escape system active to ensure the crew can be safely pulled away from the rocket in the event of an emergency during fuel loading. The first uncrewed test mission, Demo 1, launched to the International Space Station, ISS, on March 2, 2019. After schedule slips, the first crewed flight, Demo 2, launched on May 30, 2020. SpaceX planned a series of 4 flight tests for the Crew Dragon 2, a pad abort test, an uncrewed orbital flight to the ISS, an in-flight abort test, and finally, a crewed flight to the ISS, which was initially planned for July 2019, but after a Dragon capsule explosion, was delayed to May 2020. The Crew Dragon pad abort test, also officially known as the SpaceX pad abort test, was conducted successfully on May 6, 2015, at SpaceX's Lease Space Launch Complex 40, SLC-40, sometimes referred to as Slick 40, launch site. Dragon landed safely in the ocean to the east of the launch pad 99 seconds after ignition of the Super Draco engines. While a flight like Dragon 2 and trunk were used for the pad abort test, they rested atop a truss structure for the test rather than a full Falcon 9 rocket. A crash test dummy embedded with a suite of sensors was placed inside the test vehicle to record acceleration loads and forces at the crew seat, while the remaining 6 seats were loaded with weights to simulate full passenger load weight. The test objective was to demonstrate sufficient total impulse, thrust, and controllability to conduct a safe pad abort. A fuel mixture ratio issue was detected after the flight in one of the 8 Super Draco engines, causing it to underperform, but did not materially affect the flight. On November 24, 2015, SpaceX conducted a test of Dragon 2's hovering abilities at the firm's rocket development facility in McGregor, Texas. In a video, the spacecraft is shown suspended by a hoisting cable and igniting its Super Draco engines to hover for about 5 seconds, balancing on its 8 engines firing at reduced thrust to compensate exactly for gravity. The test vehicle was the same capsule that performed the pad abort test earlier in 2015, it was nicknamed Dragonfly. In 2015, NASA named its first commercial crew astronaut cadre of 4 veteran astronauts to work with SpaceX and Boeing, Robert Louis Behnken, Eric Allen Bowe, Sunita Lynn Williams, and Douglas Gerald Hurley. The Demo 1 mission completed the last milestone of the Commercial Crew Development Program, paving the way to starting commercial services under an upcoming ISS Crew Transportation Services contract. On August 3, 2018, NASA announced the crew for the DM-2 mission. The crew of 2 consisted of NASA astronauts Bob Behnken and Doug Hurley. Behnken previously flew as mission specialist on the STS-123 and the STS-130 missions. Hurley previously flew as a pilot on the STS-127 mission and on the final Space Shuttle mission, STS-135. The first orbital test of Crew Dragon 2 was an uncrewed mission, commonly called Demo 1, and launched on March 2, 2019. The spacecraft tested the approach and automated docking procedures with the ISS, remained docked until March 8, 2019, then conducted the full re-entry, splashdown and recovery steps to qualify for a crewed mission. Life support systems were monitored for the entirety of the test flight. The same capsule was planned to be reused in June 2019 for an in-flight abort test before it exploded on April 20, 2019. On April 20, 2019, Crew Dragon C204, the capsule used in the Demo 1 mission, was destroyed in an explosion during static fire testing at the Landing Zone 1, LZ-1, facility. On the day of the explosion, the initial testing of the Crew Dragon's Draco thrusters was successful, with the anomaly occurring during the test of the Super Draco abort system. Telemetry, high-speed camera footage, and analysis of recovered debris indicate the problem occurred when a small amount of dinitrogen tetroxide, N2O4, leaked into a helium line used to pressurize the propellant tanks. The leakage apparently occurred during pre-test processing. As a result, the pressurization of the system 100 milliseconds before firing damaged a check valve and resulted in the explosion. SpaceX modified the Dragon 2 replacing check valves with burst discs, which are designed for single use, and the adding of flaps to each Super Draco to seal the thrusters prior to splashdown, preventing water intrusion. The Super Draco engine test was repeated on November 13, 2019, with Crew Dragon C205. The test was successful, showing that the modifications made to the vehicle were successful. Since the destroyed capsule had been slated for use in the upcoming in-flight abort test, the explosion and investigation delayed that test and the subsequent crewed orbital test. The Crew Dragon in-flight abort test was launched on January 19, 2020, at 15:30 Coordinated Universal Time from Launch Complex 39A, LC-39A, on a suborbital trajectory to conduct a separation and abort scenario in the troposphere at transonic velocities shortly after passing through max Q, where the vehicle experiences maximum aerodynamic pressure. The Dragon 2 used its Super Draco abort engines to push itself away from the Falcon 9 after an intentional premature engine cutoff, after which the Falcon was destroyed by aerodynamic forces. The Dragon followed its suborbital trajectory to apogee, at which point the spacecraft's trunk was jettisoned. The smaller Draco engines were then used to orient the vehicle for the descent. All major functions were executed, including separation, engine firings, parachute deployment, and landing. Dragon 2 splashed down at 15 hours 38 minutes and 54 seconds Coordinated Universal Time just off the Florida coast in the Atlantic Ocean. The test objective was to demonstrate the ability to safely move away from the ascending rocket under the most challenging atmospheric conditions of the flight trajectory, imposing the worst structural stress of a real flight on the rocket and spacecraft. The abort test was performed using a Falcon 9 Block 5 rocket with a fully fueled second stage with a mass simulator replacing the Merlin engine. Earlier, this test had been scheduled before the uncrewed orbital test. However, SpaceX and NASA considered it safer to use a flight representative capsule rather than the test article from the pad abort test. This test was previously planned to use the capsule C204 from Demo 1, however, C204 was destroyed in an explosion during a static fire testing on April 20, 2019. Capsule C205, originally planned for Demo 2, was used for the in-flight abort test, with C206 being planned for use during Demo 2. This was the final flight test of the spacecraft before it began carrying astronauts to the International Space Station under NASA's Commercial Crew Program. Prior to the flight test, teams completed launch day procedures for the first crewed flight test, from suit-up to launch pad operations. The joint teams conducted full data reviews that needed to be completed prior to NASA astronauts flying on the system during SpaceX's Demo 2 mission. On April 17, 2020, NASA Administrator Jim Bridenstine announced the first crewed Crew Dragon Demo 2 to the International Space Station would launch on May 27, 2020. Astronauts Bob Behnken and Doug Hurley crewed the mission, marking the first crewed launch to the International Space Station from U.S. soil since STS-135 in July 2011. The original launch was postponed to May 30, 2020, due to weather conditions at the launch site. The second launch attempt was successful, with capsule C206, later named Endeavour by the crew, launching on May 30, 2020, 1922 Coordinated Universal Time. The capsule successfully docked with the International Space Station on May 31, 2020, at 14:27 Coordinated Universal Time. On August 2, 2020, Crew Dragon undocked and splashed down successfully in the Atlantic Ocean.